Hello? All right. So good afternoon, everyone. My name is Martyn, and I'm a sales engineer for InterSystems. And today, I'll be sharing how generative AI combined with vector search and RAG is already being used in healthcare to deliver faster and more reliable answers. So with that, cool. With that, let's start with a simple question. What if the answers we need were already in our data, but we just couldn't reach them fast enough? AI is no longer just for the moonshots. It's showing up in our day-to-day. And it's helping clinicians work faster, helping staff work smarter, and helping patients get what they need sooner. Ooh, sorry, I jumped the gun a little. So, but to get there, we must, I'm sorry. But to get there, we must face the reality. Healthcare data is fragmented, messy, and siloed. And AI is only as good as the data it sees. We have all heard the saying, garbage in, garbage out. And it applies here more than ever. An AI model, no matter how powerful, it won't give you useful answers if the data is incomplete and inconsistent. That's why, before you can do AI well, you need a platform that brings it all together. And that's the real challenge. So AI's arrival in healthcare comes with immense promise. Modern AI techniques, from machine learning to generative AI, are already demonstrating their values in such as these. In imaging, it can detect subtle abnormalities that even trained eyes might miss. In decision support, it surfaces the right knowledge at the right time. For patients, AI assistants could keep engaged with patients between the visits. In drug discovery and research, it could help by spotting patterns that humans would take years to untangle. And lastly, administrative and operation efficiency. It lightens the load by automating things like coding, documentation, and freeing clinicians to focus on care. So yes, the opportunities in AI in healthcare are enormous, but it isn't that simple, isn't it? Data comes from everywhere: EHRs, labs, wearables. And clinicians won't rely on AI unless they see not just the answer, but the reasoning behind it, the why. Add privacy concerns, and a single breach just doesn't cost only money. It costs trust. And this trust doesn't come from demos, it comes from the systems that work where care happens. And so, now for the sponsored segment of this presentation. This is where InterSystems Iris for Health comes in. We already know that Iris for Health is a comprehensive data platform and integration platform specifically designed for healthcare. For things, it provides all the building blocks that makes our platform AI ready, like having support for healthcare standards like HL7, FHIR, to powerful data management like security and analytics. In fact, we already know we are a leader in healthcare data technology and interoperability, managing over 1 billion patient records globally in mission-critical systems. What sets Iris apart is that it's a unified platform, not just as a database or an interface engine, but it brings everything together needed to deploy AI and healthcare in one environment. Multimodal storage, vector search, capabilities, interoperability. Iris is unified not just in name, but in architecture. No stitching together of ETL servers or ML servers, vector databases, or brokers. It's already there, one stack, one platform. So with that, let's look at how AI is making a real impact today, not 10 years from now, and how Iris for Health is helping to make that happen. All right, so the first use case is enhancing patient communication. Bay State Health was drowning in thousands of patients' messages. Each day, most of these messages were routine, some of it was urgent. Quite immediately, the risk was obvious. There was no fast way to separate the routine messages from the high-risk ones. So they turned to Iris for Health in AI. From day one, the model triaged messages automatically, About 6% flagged as urgent, routed straight to the care teams. No extra system to log into, no disruption. It just provided better visibility in the workflow. AI also started auto-handling requests, routines, about 15% of the volume. So this frees up staff to give more higher priority care. And now they're already testing generative AI to summarize long messages into short, actionable notes. This is RAG in action. Personalized answers grounded in patient context, delivered right inside the workflow. Integrated, invisible. For our next use case, I want to talk about augmenting clinical decision-making with AI. One of the most powerful roles in AI for healthcare is probably co-pilots for clinicians. Nobody can read every study or recall every detail of a complex case in a moment, but an AI assistant personally could, or rather could help you with that. With RAG, the system doesn't rely just on training data. It looks up real-time patient records, labs, medicals, and guidelines before answering. That means the advice is specific and sourced. So we take a patient with diabetes, hypertension, and other various health complications. Instead of a textbook reply, co-pilots can recommend safer drug choices or reference the latest guidelines, all in real time. That's what I call true clinical decision support. And more importantly, and you would hear this reiterated throughout this event, this doesn't replace the clinician. It augments them, helping care teams make faster, safer decisions with AI in the loop. For our next use case, let's talk about something every clinician knows too well: documentation. We all know it eats time, notes, charts, summaries. But what if AI could take away some of that? We are seeing systems that can. With consent, AI listens in the exam room, not just transcribing, but understanding. It drafts summary, highlights risks, or even suggests next steps like tests or referrals. Kind of like IntelliCare. Take a patient who mentions they're a heavy smoker. The AI flags it and recommends it a lung screening. Not a guess, but it's grounded in what it heard in the room, with reasoning that you can trace. That kind of transparency builds trust. Behind the scenes, the transcript is stored securely and indexed for meaning, tied back to its original words. That's RAG in action, giving clinicians not just smart answers, but actionable ones. The payoff: less time typing, faster, more informed decisions, and insight backed by data you can verify. That's the real promise of AI in healthcare. Not replacing the clinician, but working alongside as a researcher or a scribe, turning documentation from basically a burden to an ally. For the last use case I'll be talking about today, we'll be switching gears for a moment, because healthcare isn't only about care at the bedside. It's about making sure the correct people and the correct resources and the processes are all lined up nicely together. Take missed appointments. They waste time and delay care. With smarter reminders and targeted outreach, what we could achieve is that hospitals could fill more extra slots and cut no-shows significantly. An example is the King Khalid Eye Specialist Hospital. They did the same. Fewer calls, 40% no-shows. 40% fewer no-shows, The same approach works for operations. Forecasting ICU surges, predicting surgical kit demand, and even spotting supply chain risks before they disrupt care. And on the admin side, smarter coding and billing, things like this. The result is simple: smoother hospitals, less admin, and more time for the patients. So with that, I would like to take a closer look into the main two things that I would like to talk about in these presentations too: RS vector search and RAG. So we'll start with vector search. It's not, okay. Traditional databases right here are good at exact match. Find me patient ID 123, select all records from something where diagnoses equals X. But we know human language doesn't work the same way. If someone writes pressure in chest, they might really mean chest pain. But a regular query wouldn't catch that. It's the same idea, but different words. Vector search changes that. It lets you search by meaning. And here's how. With AI models, you take a sentence or a document and you convert it into a numeric fingerprint in a high-dimensional space. Basically, you see those numbers. Similar ideas end up close together in that space. So now, when you ask a question, you're not only doing a word match, you're actually looking for conceptual closeness. And Iris does this natively. It lets you embed your data, structured or unstructured, and compare those vectors in real time. No external service, no copy-paste. It happens right inside the platform. And that's powerful for healthcare. A clinician can search, find cases like this one, and the system pulls up similar histories, labs, or outcomes, even if they were written differently. A researcher can ask, show me papers related to this rare condition, and meaningful matches will build without having, as in meaningful matches will be written without building like a perfect keyword query. That's semantic search. And once you have that, you're ready for RAG, which is the next thing I'll talk about. RAG, or Retrieval Augmented Generation, takes vector search one step further. Happens in 3 steps, or rather, here's a generic pattern. User asks question, the system uses vector search to find data, and an AI model uses that data to generate an answer. Now you're not relying on what the model memorized. You're feeding it facts, live and contextual, specific to your patient or system, kind of like giving your AI an open book exam. That matters because language models on their own don't know everything. They have training cutoffs. They can hallucinate, and they cannot see your real-time data. RAG kind of fixes that. It injects the right data into the model's thought process, grounding its response. Let's put things into perspective. With RAG, if a patient asks a chatbot, what were the results of my last MRI? AI wouldn't have any idea. But with RAG, or rather Iris with RAG, the system retrieves the MRI report, references patient history, and gives an informed answer. Same goes for summarizing long records or finding gaps in documentation. You can summarize documents with many pages into short sentences that actually mean something, not only to humans, but something that AI models could understand as well. Also, Iris Vector Search runs inside the same high-performance core that we all know about as our transactions and analytics. It's been optimized for speed using hardware acceleration under the hood. So when a doctor uses an AI to ask a question in the exam room, it responds promptly, very simply. No need to send the data out to third-party service. It stays where it belongs, in Iris, under your control. And we're not stopping there. With Iris 2025.1, we've taken a major leap in vector search performance. We've added a disk-based ANN index using the HNSW algorithm, or rather, hierarchical navigable small world. Let's call it mathematics magic. So you can run your vector comparisons over hundreds and millions of records in milliseconds. And that's not just a lab benchmark. That's production speed with production reliability. This also means if your RAG prototype works in a Jupyter notebook today, this upgrade could kind of help you build something on Iris tomorrow. Same logic, same workflow, just built on the engine that can handle real clinical workloads. This is an enterprise-ready AI infrastructure. So shout out to our technology partner, Red Pumpkin, for doing exactly this. They had a Jupyter notebook just outside of Iris, and within a few days, they managed to build something prior to this event. So here's the takeaway. When you hear terms like semantic search or RAG, don't get intimidated by the jargon. What they mean is simple. AI retrieves the right information, understands it, and it answers it based on fact. And with InterSystems Iris for Health, you have the capability today, integrated with your live data, operating securely, and built to scale. This is how we move from models that sound smart to systems that are actually smart, because they're grounded in your truth. With that, I'd like to have some closing words and reiterate some ideas. We often hear AI talked about as if it's over the horizon, but as we've seen today, it's here. AI is already triaging patient messages, so urgent cases don't slip through. It's summarizing histories and guiding decisions. What makes that possible is the foundation. We handle the plumbing so your teams can focus on solving problems. Think of it as like the city's power grid. Once it's in place, everything can move faster. Iris doesn't force a choice. It connects the old to new, bridging HL7 with Fire or SQL with JSON. It's a bridge between systems, and more importantly, between people. None of this also works without trust. Healthcare is human. The goal of AI isn't to replace that. It is to support it. And that's why explainability and governance are not optional. They are essential. With Iris, you can show your work, every recommendation traced, every rule auditable. As regulations shift, Iris could shift with you. Controls and validations built in, so when you look ahead, the future is not so abstract anymore. It's AI predicting care needs before symptoms start. It's automation removing low-value tasks so clinicians could focus on higher priority care. It's systems optimizing behind the scenes, 24/7. So let me leave you with this. AI in healthcare is here, and with the right foundation, it will take us further. Thank you, and let's get to work. Do we have time for? Do we? All right, cool. So I have a demo video of a clinical assistant. This isn't really like our official product. This was actually built by our summer intern a couple months ago this year. For some background, he built this within 3 to 4 weeks of learning Iris. Granted that he's a computer science major, the bulk of his work was actually just understanding the concepts of vectors in general. And beyond that, he basically hacked together some Python code on a notebook, and together with Iris, he kind of built this little demo. And we actually presented this to a customer. So yeah, please enjoy.
Here we have a view of what the clinical assistant front end looks like. So on the left side, we have some query filters. So we can specify which PDF which we want to run the query on, as I've just specified sample notes 2. That's the only thing which I've submitted to the database so far. And then here we have a list of patients which we want to run the query on. And I just choose this Madam A. And now we can choose or choose not to run a visit date for which visit which we would like to do the query for. Here we have a guideline source to specify. So for when we run the web search, which source we want to take the results from. And then let's just run a simple query about asking about the medications which this supposed Madam A was on. So this is just a simple query asking for a summary of whatever Madam A was on at the time of her visit. And since I specified the visit date to be January the 30th, it'll only take out results from that specific visit date. And so we can see here, this is the patient data, which it's taken from the Iris database. Here we have this one, I've labeled them P1, and this is from the 30th visit. Again, we can see Madam A, again, the 30th visit. And in this P2, we see a lot of the medication, which is stored in the database. And here's a list of guideline snippets. And this is the answer which the LLM has come up with. As we can see here, amlodipine, nifedipine, all these, and these are all backed up in this P2 entry in the database right here. And it mentions as well here that it's taken this information from P2.
All right. I don't know, maybe the video got cut off, but thank you very much, ladies and gentlemen.